Welcome back to Forge College's Solidity from Zero Track. I'm your host, and today we're bringing our smart contract data to life with advanced event handling techniques. In this explainer, we're going to look at building off-chain consumers for event processing. Because look, if you've been following along, you already know that emitting an event on the blockchain, that's really only half the battle. Today, we figure out how to actually catch it. Let's dive in.
So in our previous lesson, we carefully designed the signals that our smart contracts emit, right? We talked all about index parameters, optimizing data payloads, the whole shebang. But emitting an event is kind of like shouting into the void. Now we actually have to engineer the machine that listens to that screaming void of the blockchain and, makes sense of it all.
Here's our schematic for today. We're going to break down the off-chain consumer, look at push versus pull patterns, figure out how to filter blockchain noise, handle those pesky reorgs, structure your log data, and finally, do a test run of our machine.
Section 1. The off-chain consumer. Let's start with the literal first component of our blueprint.
Okay, so think of this off-chain consumer as your polite yet completely exhausted secretary with a clipboard, trying desperately to make sense of a highly chaotic data network. Technically speaking, it's typically just a small Node.js script, using libraries like ethers.js that connects to an Ethereum-compatible provider. Its entire job, literally, is to sit off-chain, listen for very specific on-chain logs, and reconstruct those into concrete structured interactions so your databases, metric systems, or notification bots can actually act on them.
Section 2. Push versus pull patterns. So how exactly does our hardworking secretary get this data from the blockchain? We basically have two-man approaches here. Push is like someone eagerly shoving data into your hands the exact moment it's ready, using a WebSocket subscription to send logs in real time. Pull, on the other hand, is you constantly asking the node, are we there yet? Any new logs? How about now? Every 5 seconds using periodic JSON RPC polling, specifically the eth_getLogs method. Push gives you that sweet low latency, for sure, but pull gives you incredibly predictable batch processing and makes recovering from downtime a whole lot easier.
Moving on to Section 3. Filtering blockchain noise.
Because we definitely do not want to process the entire history of the blockchain just to find our one little transaction.
To build a really tight filter, you have to specify the exact contract address, define a strict block range, and provide the event signature topic. But the real magic happens when you utilize those indexed fields we talked about last time. By querying specific indexed fields, like, say, a specific sender address, you create a highly narrow query. This absolutely drastically reduces the network load and your node costs. You're saving money here, folks, because the provider doesn't have to send you a literal mountain of irrelevant logs.
All right, Section 4. Handling blockchain reorgs. Let's move to the safety mechanism of our machine.
So what happens when the blockchain gaslights you and changes its mind about what just happened? I know, it's a funny question, but it's a very real problem. Because decentralized networks take a bit of time to reach consensus, sometimes the chain reorganizes. This means a block that was just added might suddenly be discarded in favor of a longer, heavier chain. If your consumer script processed a log from that discarded block, well, the blockchain effectively just gaslit you. The events you just processed might disappear completely or change order. No way we can let that slide. To prevent total chaos, we engineer a confirmation window. You should never, ever implicitly trust the very tip of the chain, the current block with 0 confirmations. Instead, we wait for a safe head, say 6 block confirmations behind the current tip. Furthermore, we keep a checkpoint file on our server tracking the last processed block, and we maintain a reorg buffer, maybe 12 blocks deep. This means when our script restarts, it looks back 12 blocks before the last processed block, just to double-check that history hasn't quietly shifted while we were asleep.
So our exact polling loop logic works like a well-oiled machine. Step 1, read the checkpoint clipboard to see exactly where we left off. Step 2, calculate the safe head block to avoid that volatile tip of the chain. Step 3, query the filtered logs using our indexed topics. Step 4, parse those raw, messy logs and save them as neat records. And finally, Step 5, write the new block number back to the checkpoint clipboard. It's a continuous, self-healing loop. Pretty brilliant, right?
Which brings us to Section 5, structuring your log data. Next up on the assembly line.
Raw blockchain logs are highly technical and awkwardly split between topics and data. So we absolutely have to map our event parameters into a stable JSON schema. We turn smart contract variables like the indexed from address into a nice clear sender field. We take the non-indexed uint256 value and parse it into an amount field. We do this so that your downstream systems, like your slick web dashboards or email alerts, don't suddenly break when they're confronted with raw blockchain hexadecimals.
Now, the absolute crucial piece of the puzzle here is your metadata. Think about it. If your chain reorgs and your consumer script queries the same block twice, how do you prevent counting a transaction double? Well, you must include the block number, the transaction hash, and the log index in every single JSON record you output. The combination of these three variables creates a unique identifier. This allows your downstream database to safely deduplicate and strictly order your events. It guarantees eventual consistency.
Almost done. Section 6, Testing and Next Steps. It is time to flip the switch and give our listening machine a real test run.
Look, a consumer script is truly only as good as its ability to recover from a crash. So the ultimate test is this: intentionally kill your consumer script. Just stop it. While it's dead, trigger a test transaction on your local network or testnet. Then turn your consumer back on. Because of your checkpoint file and that reorg buffer we just built, it should wake up, realize, oh wait, I missed some blocks, look backwards, and automatically detect and recover that missed event perfectly. If it prints the correct JSON line to your console, boom, your safety mechanism works, giving you total peace of mind in production.
So let's quickly recap the core principles that make an off-chain consumer resilient and scalable. First, tight filters save money and time, so always use indexed fields. Second, robust checkpointing and a reorg buffer protect you from blockchain gaslighting. Third, structured metadata with transaction hashes is absolutely mandatory for deduplication. And finally, choose your architecture wisely. Push for speed, pull for reliability.
Coming up next time, performance and security considerations for event handling. Now that we have a functional machine that can pull logs and survive a crash, we need to talk about scale. Next time, we are going to scale this machine up to handle massive transaction volumes and protect our pipelines against malformed, malicious logs that bad actors might try to inject into our consumer. But for now, I want to leave you with this question. Where will your newly structured records land? Are we talking a message queue, a database, or a metrics system? Now that you've transformed raw blockchain noise into perfect JSON records, where does this data assembly line actually lead? Think about the architecture of your specific application. And remember, if you want to dive deeper into this and get your hands on the actual Node.js code we discussed today, head over to forge.college to learn more about this and other Web3 engineering topics. Thank you so much for joining me on this explainer from Forge College, and I will see you in the next one.